This video is going to explain how to solve quadratics by factoring. When you want to solve a quadratic, solving quadratics means that your answers will look like x equals or whatever variable you have, but it's equal to. You're still trying to solve it like you always have. You're going to have x equals. We're still going to factor it like normal. So a solution, because when you're solving something, you're going to have solutions. Solution is when the graph crosses the x-axis. Now you might have heard that before, another term that's used for solutions, when it crosses the x-axis, so that's another way of saying x-intercepts. So another term for solutions is x-intercepts. We've seen those before whenever we factor, when we graph. You always want your x-intercepts. I've used before in previous videos m and n. So you're actually finding your m and n value just like we have before. Other words for x-intercepts are roots and zeros, because it's when the y value is 0. So possible solutions for quadratics, you can have two solutions. Two solutions is when your quadratic, your parabola, actually crosses the x-axis twice. So it'll actually cross through, so like maybe here and here, it'll actually cross twice. So those are your two x-intercepts. So your two solutions is where the graph crosses twice. When you have one solution is actually when your quadratic will bounce. It'll have one x-intercept. It'll bounce. This is also when you have your parentheses squared. If you end up having parentheses squared, or if it's in vertex form, this is how you know it's going to bounce. So be careful with this because it does not actually go through the x-intercept. It'll just bounce on it. So this x-intercept, your m and your n value will actually be the same. And then we'll have no real solution. So we've had two solutions which are real, one solution which is also real. Then when you have no real solutions, it means that it's not crossing the x-axis. It's not crossing the x-axis. It still has a vertex and it still has a y-intercept, but it does not cross the x-axis. You still technically have solutions, but they're not real. So what that means is that you actually have two imaginary solutions. So an example of this is to get imaginary numbers when you have the square root of a negative number. And if you take the square root of a negative, you'll actually see that it says non-real. So I actually type one in. So I type in the square root of -7. I will actually get an error. It says non-real answers. It's because you are dealing with non-real, which are imaginary. So the way we would write this is that negative inside the radical actually becomes an I on the outside of the radical. And then we're just left with the square root of 7. That negative, when it's inside of a square root, it actually just comes to the outside and it becomes an I, because that's an imaginary number is the square root of a -1. So that's really -1 times a +7. So that I is the square root of -1. That's where that negative actually goes. So we'll see quite a few of those. Factoring, if you're going to solve by factoring, it has to cross twice at two rational values, or it has to bounce at a rational value. If you're factoring, you can never get imaginary solutions, because if it's imaginary, it does not factor. So to solve by factoring, our steps are set the equation equal to 0. We're going to factor it using MACAB or grouping or difference of squares. Then we're going to set each factor equal to 0, which was that 0 product property. We're going to solve for your x. Now again, that's just the get your x-intercepts, your m and n value, as you've always done when we put it into intercept or factored form, and we graph them. So we're going to get our problem set equal to 0, so we've got to put this into standard form. We have our positive x squared, and remember, your x squared always wants to be positive, so any way you can keep that positive, keep it. That means that we want to take this negative 4x and move it to the other side. So we're going to add the 4x to both sides. So we're going to have x squared plus 4x is equal to 0. When you factor, once we have set equal to 0, you factor. You always factor your GCF first, no matter what. So we have two terms right here. We're going to factor our GCF, which our smallest number is 1, but as you can see, both of these terms have an x in it. We don't focus on the equal 0 having anything, because that's how we're going to solve, but we look at our terms together in standard form. They both have an x with it, so that means our GCF is actually equal to x. I'm going to write that out. GCF equals x. So GCF is always on the outside of the parentheses. Now I'm going to divide everything by this x. X squared divided by x is x. 4x divided by x is just a positive 4 equals to 0. I'm not going to say I'm finished factoring yet because I still have to check inside the parentheses. Inside the parentheses, I have two terms, so I would look for a difference of squares. The first term is x is not a perfect square, therefore I know that I cannot factor this further. What that means is that I need to go ahead and set each factor equal to 0. Now, each factor is also anything that has a variable with it. So even though this part is not in parentheses, this is one of my factors because it was my GCF. So I have to take this factor and set it equal to 0. So I take this x and equal it to 0. Then I see that inside the parentheses I still have a variable. So I'm going to take this factor, this entire x plus 4, and equal it to 0. Because again, I need to know what value will make it 0 because it needs to be a y equals 0. I have two x values. That means that it should cross twice. So I just need to solve. This x value is already solved. So my x is equal to 0. That means that my coordinate would be 0, 0. It would cross through the origin. This one, I will need to subtract 4. So my x value is equal to a negative 4. So our two x-intercepts would be at 0, 0 and negative 4, 0. So our solutions are x equals 0 and x equals negative 4. Now because we have two numbers, we have two answers, these are real because we never dealt with the square root of a negative. They are rational because they can be written as fractions. This has, I'm just going to make a note, this has two real rational solutions. We always want to see that because in the future we're going to have to know how many solutions, real or imaginary, rational or irrational, that we'll end up having before we even do anything. So since we have two real rational solutions, that means that the parabola crosses the x-axis twice. The parabola crosses the x-axis twice. On this next problem, we again want to make sure it's in standard form. We look at our x squared, our quadratic term, and that is already a positive. So we want to get all the other terms to the other side. We want to move those by subtracting the 5x and subtracting the 2. So I'm going to subtract the 5x and subtract the 2 from both sides. Now we have a 3x squared, so I can't actually connect or turn the 3 minus 5. I can't actually combine those. So we're going to have a 3x squared minus 5x minus 2 is equal to 0. Now that it's in standard form, I can factor. Whenever we factor, we always do our GCF first. GCF, our smallest number is a 2. So we look, can 3 be divided by 2? It cannot. Then our GCF would have to be a value of 1. We have an x, and no x. That means our GCF is just 1. So it will not affect the problem any further. Now, we still have 3 terms left over. So in order to factor out our 3 terms, we would use MACAB, or another term of that is AC method. So we have to know what our A, B, and C are. A is equal to a 3, B is equal to a -5, and C is equal to a -2. So our MACAB. Our MAC is our 3 times -2, which is -6, and our AB is -5. So what multiplies to 6 is 1 and 6, 2 and 3. So in order to get 1 and 6 can give us a 5 if we do 1 minus 6. So a +1 minus 6. And we can get 2 and 3 to give us a -5 by doing -2 and -3. Now, since both of these could potentially work to get our AB, we have to make sure they MAC correctly as well with their signs. So a +1 times a -6 is a -6. So this one does work. But a -2 times a -3 does not give us a -6. So this one is bad. We want the +1 and the -6. Now always make a little note. Since A is not equal to 1, we must use the box. So I'm going to make my box so that we can factor out our GCFs again. Now the first term in our box will be our original first term, which was our 3x squared. And the last term will be that -2 because it's at the end. Now the reason why we do that is because our 1 and -6 is what creates that -5. So we're going to split those up. We're going to have a 1x and a -6x. Don't forget that all 3 of these boxes have to share a letter in common. Now we're going to factor their GCFs. So for the first row, what they have in common is for 3x squared and 1x, it's just an x. For the second row, I see that my first term is negative, so I know my GCF will have a negative. And what's common between 6 and 2 is 2. These do not share an x, so it's just 2. Now going out for my first column, I have 3x squared and -6x. Since my first term is a positive, I know this will be a positive. So GCF of 3 and 6 is 3. And then x squared and x is x. So that GCF is 3x. For the next column, I see that my first term is a positive, so I know this will be a positive. GCF of 1 and 2 is just a 1. And the first term is the only one that has the x, so I know that my GCF will not have an x. We have now factored this, so if I write it in factored form, I take my 3x plus 1, put it into its own factor. And then my second part, that x minus 2 is a factor. And I set it back equal to 0, just like the original one. So 3x squared minus 5x minus 2 factors to be 3x plus 1 and x minus 2. Now that it's factored, we set each factor equal to 0. This first set of parentheses does have an x in it, so I want to make sure I take that 3x plus 1 and set it equal to 0. The second set also has an x in it, so I take that x minus 2 and also equal to 0. Now again, I'm just finding our m and n value. So if I want to solve for this first one, I know I'm going to have to subtract the 1, but because I have a 3 attached to the x, I'm going to have to divide by that 3. So I subtract the 1 and then divide by that 3. So that x value is equal to a -1, and then I divide it by 3. On the second one, I'm going to have to add the 2 to the other side, so it'll be x is equal to a +2. These are our 2 solutions. Now, we did not have to take the square root of a negative, and because it was factorable, we know that we will have real rational solutions. Since we have 2 of them, we can say that we have 2 real rational solutions. Make that little note down here. 2 real rational solutions. Because it was factorable, we knew that we were going to have real and rational. It just depended on how many we were going to have. So real and rational, because it's factorable, we're going to have real and rational. This also means that our parabola will cross the x-axis twice. Now, -1/3 is rational because it can be written as a fraction. So again, since it was factorable, we would have real, rational. The amount of factors it has determine if we would have 2 or 1.